Hi, everyone. I'm Esha Mallya, and I'm a security engineer focused on infrastructure security at DoorDash. I have several years of experience in different security domains and have held a few odd software developer jobs prior to that. And prior to that, I worked in telecommunications before landing a security adjacent job, which I used to pivot into security. I've rarely had the opportunity to work on a team with women. And so I'm doing all that I can to bring more women into security and into tech in general, which is what brings me here today. Apart from that, I've also been part of smaller security teams, which often end up supporting a much larger engineering organization. So our teams often are seen as bottlenecks for pull request reviews. And being security minded, I'm always worried about what bugs might be pushed out with the next change and how it might come back to bite us. Developers, on the other hand, in an effort to be quick and fast, they're always looking to see if they can get a free pass on their pull request reviews. So to balance supporting a larger organization while being a part of a much smaller team, but also not compromising on security, I automated security reviews for infrastructure PRs. I focused on infrastructure PRs because that is my area of expertise. However, the same methodology that I'm going to discuss in this talk today can be applied to other areas of security as well, such as authorization. So in this session, I'll cover how I automated my way out of reviews using Conftest, Atlantis, and GitHub status checks. So on a typical day, a developer would pull up, would come into work and make some modification to infrastructure and put in a request for a pull request review from a security engineer. And then they would wait for a bit, maybe get some coffee, work on something else, come back, see that they hadn't received a review yet, and they would ping me again. And this would happen a few number of times. They would finally receive a review, and then they would address the comments on the PR, and then reach back for another set of reviews. And on receiving the final stamp and thinking that, yay, they're all set, they would go back to apply their changes. But now they realize that their branch is out of date with the main. And so the cycle repeats. And as you can expect, this very quickly became a bottleneck and a source of frustration for a lot of developers. On the security engineering side, the constant barrage of PR requests very quickly tired us out. Even the most seasoned security engineers were very frustrated. It became apparent that we would need to automate this in order to move forward and to keep, the peace. So since my focus is on infrastructure, I decided to try and automate only this area. I asked for help from the rest of my team in order to get started because we needed to start documenting the different types of PR requests that came our way that did not really require a security review or that was a trivial security review. I depended on my entire team to help with this, and they delivered a very rich database that I could work with. So keep in mind that these were all infrastructure related. So all of them were in Terraform and use the HashiCorp configuration language. Before talking about OPA, which I used for automating this, in the next slide, I will briefly go over Terraform for those of you who may not be familiar with it. What is Terraform? Well, Terraform is a number of things, but to me, it is most known as a way to provide a methodology to write infrastructure as code using HCL. In order to define infrastructure in the form of code, one needs to use something called a provider. A provider is that which talks to a system that you're trying to manage. So Terraform has a number of providers for a number of things like GCP, Okta, AWS, etc. And as long as you have access to the system APIs that you're trying to write code for, You can also build your own provider. I did this as a part of a different project for Splunk. On configuring these providers the right way, we can use Terraform to create, update, and delete resources within these systems. So what are resources? Resources are an element that describes individual objects within a provider. For example, a security group is a resource. An IAM user or role or policy is a resource. And each resource has a set of attributes that the user can control via Terraform, just like you would via the console. Now, apart from resources, Terraform also supports something called data sources. And data sources is a method to retrieve information about existing resources for current use. Within Terraform, the current system state is maintained in a Terraform state file. A Terraform state file is nothing but a simple and possibly really large JSON file. So on any changes made to the infrastructure resources, Terraform will first display to the user the plan for what changes are going to be applied. And this plan will show all the changes to be applied and what the previous state was, and needs to be thoroughly reviewed before the actual trigger apply is made. So a Terraform apply triggers the changes in infrastructure and also updates the Terraform state file. HCL, the HashiCorp configuration language, supports a number of built-in functions. It supports loops, variables, locals, and modules. And modules are super interesting to me because you can build a secure module which consists different types of resources, and you can use that as a template to repeatedly stamp out a set of similar resources that are frequently used together. And you can be pretty sure about how secure these modules are, provided you lock down the input variables to the modules. So Terraform allows you to translate infrastructure to code, and along with version control, it gives you a way to, audit and hold people accountable for their changes. And it also gives you a single place to view all of your infrastructure code. So with all of that background, and since Terraform is what I used, so Terraform plan is what I used to automate most of this, let's go into the real meaty part of my session today, which is Open Policy Agent. Open Policy Agent, also called OPA, is a policy agent that understands a high-level declarative language called Rego. OPA is open source, and it's very, very flexible. Some people in security may say it's too flexible because you can specify any policy on any principle using any data as input. So for our use case, we needed to build policies for Terraform code, and we implemented these policies to block all by default. To build these policies, we needed to view a Terraform plan that shows the resources that were going to be changed and that we were looking to allow. So how do you do this? How do you view a Terraform plan? You do this by running the Terraform plan command and saving that output in binary format using the out flag as shown on the slide. And then you follow it up with the Terraform show command. The plan would demonstrate the changes that are being proposed, and the show command would translate the binary output from the plan command into JSON. And then this plan JSON is then used as an input to Conftest. We haven't spoken about Conftest yet, but I'll talk about that in my next slide. Conftest is an OPA utility that we used to automate this entire system. So I know the title for this slide is rather wordy. However, the solution that we came up with needed all of these different components for it to work together. So we used Atlantis, Conftest, and GitHub status checks. Atlantis is a wrapper around Terraform running against pull requests that allows us to use Terraform as a team. So it allows different members of the team to contribute to the same code without leading to, configuration issues or actual infrastructure changes that are overwritten by one another. It does this by managing Terraform state lock. And so whoever has the state lock is the one who is able to write to infrastructure. So the Terraform state lock prevents others from acquiring the lock to write to the state file and prevents state corruptions. Conftest is an OPA utility, as I mentioned before, and it provides a CLI interface to use OPA. It can evaluate each policy against a Terraform plan, which is in JSON format. The command to do this is displayed on the slide, and the policy directory part is the directory containing all of the policies that we want to evaluate against the plan file, which is in JSON. So on completing evaluation, Conftest results are posted to GitHub pull request statuses using the GitHub API. And then this status is checked by our code review system. The one that I'm familiar with is pull approve. You can use any other code review system in order to enforce how these status checks are going to be implemented. So the way we configured this is if Conftest passes, no additional human review was required. However, if Conftest fails, a human from the owning team must review the changes and can override OPA status results. In order to roll this out quickly, as I mentioned, I had a very rich database of PRs that I could automate, but I wanted to minimize the number of PRs that required human reviews. So in order to automate this as quickly as possible, I decided to section the rules into 3: approved modules, approved resources, and some resource-specific attributes. I focused only on resource creations and updates. I didn't really focus much on delete. Now, approved modules were those modules that were deemed to be secure enough and didn't have a lot of input variables that could make the module insecure and were allowed to use because they were already vetted by security. Approved resources were very similar to approved modules. They had a low risk and were allowed for use. Extending OPA to approved modules and resources was trivial. However, resource-specific rules were harder because only certain attributes of certain resources needed review. And this is where the complexity of the rules started to come in. I'll show you examples of code for these rules in one of my later slides. Using a baseline template rule for allowing certain attributes for a resource helped manage these more complex use cases for me. So I came up with this template that would work frequently with minimal edits. And I mostly had to only replace the resource type and the allow listed attribute type, and it would work, except for some corner cases where there were inline attributes and things like that. And also when talking about resources, we were mostly interested in creation and modification, as I mentioned. We were not interested in deletion because those were very few PRs that came our way, but extending OPA to deletion is not a lot of effort. However, it didn't make a lot of sense for us at the time because deletion PRs would have to go through review, manual review anyway, since we were blocking all by default. So Atlantis, Conftest, and GitHub status checks displayed in this manner. So in the first image, you can see that there were 8 policies or tests that were evaluated against an infrastructure PR. 6 of these tests passed and 2 of them failed. You can make the messaging there as descriptive as required in order to identify which specific test failed, which is something that we did after I took the snapshot. However, you can display any messaging over there in order to help track down exactly what rule failed and what would need to be corrected by the developer in order to get this to a passing state. In case there's no correction a developer can make, then a security review is required, as shown in this image. And the second image is where the OPA status checks state is displayed. So you can see a big red cross over there, meaning it failed, and it requires a human to perform a review to override it. On this slide, hang on, I have to switch tabs over here. So on this slide, I've shown a sample Terraform state file code. So when you perform the plan and then you change, you use Terraform show to change it into JSON, you see something like what is displayed on the left-hand side of the screen. So you would see, the format, the Terraform version, variables, plan values, etc. The most important of these for our purpose is the resource changes that Terraform is proposing to make. Now, I've double-clicked on this, and you will see specific resource changes that are to be made in this plan on the right-hand side. In this, you can pretty quickly look at the right-hand side and go, oh no, this is absolutely not okay, because this is creating an AWS security group. That's the resource type. And it's looking to create it instead of updating or deleting it. So the change and actions tells you what kind of action it is looking to take. And then you can see on the ingress, it's opening up to the entire world from port 0 to 65535 over TCP. So this is definitely a case that you want to catch. And you will see such similar resource change plans for every resource. For a module, you would see an additional key within the JSON file which says module address, and you can look up that specific module address to see if the module is allow listed or if you want to check some specific attributes related to the module. In this slide, I'm showing sample Terraform code and an OPA rule that allow lists one resource that is defined in Terraform. So on the left-hand side is the resource in Terraform. I'm trying to create or update an AWS app auto-scaling target resource type. And this is considered low risk from our perspective, which is why on the right-hand side, you can see the OPA rule that allows it. So I want to explain the OPA policy over here a little bit more. The core of every OPA policy is the deny message from our perspective. So the first thing it does is it checks if the action, as we had seen in the previous slide, so the action, the change actions, is no op, meaning no operation, no change to the resource, or if it is anything other than, if it's anything, it's trying to confirm that it's not no operation and it's not read-only. So it can be create, update, or delete. And then it's trying to make sure that this change is not being triggered from inside of a module. So it is actually a resource change. And then it calls on a function, the resource not allow listed function. And it captures the resource type and makes sure that the resource type is actually allow listed. And if it is not allow listed, remember there's double negation here. If it is not allow listed, then it would deny with this plan requires security review. I hope that's clear. I'm going to open this up for questions at the end of the talk, so we can go back to this and revisit this. Moving on to the next slide, as with any other programming languages, it is important to write unit tests even for OPA. And in this slide, we have two unit tests, one for the deny case and one for the not deny case. So on the left-hand side, you want this to actually pass because you've allow listed the AWS or app auto-scaling target and the action update. So you want to ensure that the number of denies from evaluating the OPA policy is 0. On the right-hand side is the opposite of this, and the only difference is the type, the AWS security group. You want to ensure that this resource type is denied and goes through a review, which is why you want to make sure that the number of denies it gets is not equal to 0, or you could also say equal to 1 or how many ever denies. So this is an OPA policy example where I've allowed certain attributes of a resource. So once again, the core of every OPA policy is its deny message. We are trying to verify that it's not no-op and not read. And then we are trying to verify that it contains a specific resource type in this specific OPA policy. You are making sure that it doesn't come from a module address. And then you're verifying that the attributes that are modified within this plan are one of the two approved attributes. The preferred maintenance window or tags are considered to be low risk from a security perspective, which is why we have allow listed those attributes. And as long as only those attributes are being modified, the OPA policy will pass and they will not need a human review. And if it fails, the message displayed is some of the attributes require security review, so they'll have to reach out for a review. I wanted to avoid going into too many Rego specifics during this talk, but here are a few things to keep in mind. Like SQL, Rego does not have a direct way to express universal quantification for all. So you have to use other primitive constructs like negation to achieve this. You might have seen this in some of the policies that I showed you guys on some of these slides. It's on the current slide as well. It's not intuitive. In some places, you need to use double negation. And in some places, you just need to use negation in order to get that for all resource types of this format. And the second thing that I wanted to call out was when evaluating rule bodies, OPA searches for variable bindings that make all of the expressions within that rule body true. So I guess intuitively, a rule body can be understood as expression 1 and 2 and 3 and so on and so forth. So yeah, those are the two main takeaways I had while writing Rego rules. But they have a really good documentation online. So I think you'll be able to find pretty much everything you need about Rego. So what does success look like? So when a PR review comes in and when all of the policies are evaluated and they all pass, there's no deny, a developer would see this as the result. Now they would see 9 tests passed, all of the 9 tests were present, all of them passed, and the result was a success. And the OPA policy check also passed, which means they would not need another human to review this PR, thereby freeing up their time as well as our time to work on more interesting projects and things. That brings me to the end of this presentation. Thank you everyone for joining. I don't really know if I can, I'm willing to take any questions. You can submit it over chat, or I'm not sure if you can also communicate. I don't know if attendees are allowed to talk right through Hopin. This is my first time using it. So thank you, Rachel. Also, I would love to connect with all of you. My email is isha.mallya@gmail.com, and my LinkedIn is also on the slide. Please reach out and say hello. I would love to collaborate with you guys and learn what you all do. Thanks again, everyone. This was super nice. This was my first time as a speaker, and I really loved it. I would love to see more women in engineering and in security and in tech in general. So, yay. Bye.